So welcome today to Rod George, one of our local experts living in our community. Now, looking at Rod's history, he started off in radio and communications, but then he went on to the Australian Road Research Board, ARRB, which is what he's talking to us about today, and we think will be of interesting to our trucking industry. So thank you, Rod, for making your time available. I'm going to hand over to you and listen with interest. Thank you.
Okay, thanks, Kerry. I'll just start off with a short video of some of the work we did.
It's not often truck drivers get to legally burn around at high speeds on our roads, but for the past 3 weeks, that's exactly what they've been doing. The RTA-funded tests, run by a private transport research company, are designed to show the effect of weight distribution on safety. The truck undergoes 3 tests, braking in a curve and speeding around a curve. The truck's pushed to higher and higher speeds to measure when it's likely to roll with a certain weight. Outrigger wheels are attached to the side to ensure the safety of testers in the exercise. And the company is also working on other ways to increase the safety for truck drivers.
Another project we have is to design or come up with a system of giving drivers advance warning when they're about to roll over.
After the tests, each truck is given a rating for weight distribution and load capacity. They'll be testing in Armidale for the next week. Emma Griffiths, Prime Local News.
Okay, thank you. That was just an intro to some of the work we've done. As Kerry said, we'll take questions and hopefully I can answer them as we go. So also, as Kerry in the introduction, I did a traineeship, but then I joined ARB in 1977 for the heavy vehicle research. But after that, after 30 years at ARB, I joined Tallis in Bendigo, part of the Bushmaster design team. So some background on ARB, it was an independent research organisation owned and funded by the 3 levels of government, that is the federal, state and local governments. Started primarily on pavements and bridge designs after the war as a repository of information, then moved into road transport, economics and heavy vehicle research. But unfortunately today, no more heavy vehicle research, mainly pavements and safety. So this is a typical setup of some of the vehicles we tested and some of the safety equipment and training wheels we attached to them. During most of the work, we measured a number of parameters of the vehicle, including this list. I won't go through it in detail, but we measured the vehicle dynamics and other things, driver inputs and speeds and so forth. And then they are recorded in a little data logger set up as shown in here. Vehicle stability was one of the first ones we got into, and that was funded by the Australian Institute of Petroleum. And this is a vehicle, developed by Shell, which was really ahead of its time, and it achieved a high stability than a normal elliptical tanker. Most of the preliminary work is done on this tilt table to establish its roll threshold. Now the roll threshold is when these wheels on the high side lifted off the deck, and we measure the angle, and from that we express it as a fraction of gravity, G. So again, this is a test vehicle under operation, and on the back here we've got some other equipment to measure the roll angles. I'll just go through a few of the vehicles we tested, but in summary, after about a year's work, we come up with this table for suspension matching. And bearing in mind these suspensions are from the 1980s and most of them don't exist anymore. But as an example, if you had an international 4-spring suspension on the prime mover, we'd recommend you could put a BPW wide, not that one, a freighter, yes, this one maybe, that one no. So it was a way of allowing operators to optimise the roll stability of their vehicles. But bearing in mind, these are no longer available today or in use. Another project I was involved with was in main roads, Western Australia. There was an incident on fatality on the Greenmount Hill in 1994, and main roads wanted to install an arrestor bed, and they engaged us to measure the stability and safety of vehicles entering the arrestor bed. So there was a number of vehicles at a number of speeds, and I wasn't allowed to be in that vehicle. We had a driver, a stunt driver, and I had to race around and get my data logger going before and after. So here's some of the vehicles entering the arrestor bed. And there was two types of testing, one with the vehicle fully in the arrestor bed, and this one here with half in the arrestor bed and half on the road, just so we can see if there's any yawing or any twisting. So here's some of the vehicles, and so here's me trying to access the vehicle and get my data out. One of the most problem was getting the vehicle out of the arrestor bed. So here we can see one bloke being the conductor and 11 observers watching them pull the vehicle out. And I don't think they told Mr. Budget what they're doing with the vehicle either. So getting them out was a big job. So here's a little bit of the data. This is for a B double entering at 80 kilometres an hour. And we can see on this red line that braking was about 0.5, 0.7, maybe G. But during a normal brake test, it was 0.5. So this is telling us that that arrestor bed really had much more sudden deceleration than the brakes were able to apply. And this one here is for a truck trailer. Now, this green line is what of interest here. It's saying this was in 3% of rolling over because its rollover limit is just about 0.24, and we went to very close, within 3% of it rolling over. And that was with an offset. That was one wheel on the bitumen and one other one in the arrestor bed. This is the main topic of my talk today, about increasing the truck trailer mass. So 1995 regulation said that the gross combination mass must be not more than 42.5 tonne, which means the ratio between the truck and trailer had to be a ratio of 1:1. Now that had a historic meaning. It goes back to the horse and cart days, because they didn't want the cart to be heavier than the horse, and that had really flown over into the vehicles. But with industry in seeking efficiency improvements, raising that ratio above 1:1 and utilising the tandem axle loads was the easiest way to do it. So the RTA commissioned ARB to examine the effects of higher trailer loads on safety and dynamics. So we did 3 or 4 tests: constant radius, increasing speed until the wheels lifted off at roll limit; braking in a curve, measuring how much the vehicle stayed in its lane or moved into the adjacent lane; and determining the handling characteristics, understeer or oversteer; and finally the roll gradient, how much the body rolled at increasing speed. So these were the test vehicles. So the one in yellow is a standard 1:1 ratio, and these ones in green are the 1:1.2 that we were aiming for the increases. We also tested a B double and a single articulated. RTA wanted to see the same, just for comparative reasons or purposes. So here's some of the tests, or some of the test vehicles after braking and circle tests. As you can see here, this one's got quite a high roll angle on it. That's me in the cab there on the computer. So here we're measuring the braking distance. And of course, during all these tests, it's important that we monitor the control variables, that is the tyre pressures and axle loads. So I had the RTA blokes on a string, and I could get them whenever I wanted to measure the axle loads. So that was the circle test. Now the dynamic test of the lane change, it's sometimes called real amplification. So it's the increased lateral movement of the trailer beyond the prime mover. And to do that, there's a standard test, and we're asking the driver to follow these white markers, as we saw in that earlier video. So this test, this is the depiction of what we're asking the driver to follow. So it's got an offset of 1.4 metres over 61 metres, and he has to travel that at 88 kilometres an hour. So it's quite a strict requirement. So each vehicle, we have to do this about 4 or 5 times to get the data. Now this is some of the data I recorded. So here is the prime mover, I'm 1.51, which is what the test required. So the trailer was 0.2. So in this case, it's had a ratio of 1.47. Now, there's no right or wrong answer. All it allows it is to compare the vehicles, and we can rate them according to that. Here's an old video of the tests. Oh. So the outcomes of these tests were that Vic Roads then joined with RTA and engaged the National Transport Commission to implement the recommended outcomes, which were to raise the ratio up to 1.25. But however, there were some conditions on it that there was like the suspensions and actual spacings, which is now being implemented. Another test we're involved with was the ambulances. The Ambulance Victoria were changing from Ford to a General Motors vehicle, and Vic Roads got in on it, and they were concerned about the dynamics and handling of those new vehicles. So we were engaged to conduct stability and ride comfort and handling tests on both vehicles. This was done at Mangalore Airport. So again, it was the same type of test, same type of instrumentation, and we did stability tests first. So here's my boss giving me a hand. Now, you might notice he's got no PPP on. So the ones were done in 1994, so that wasn't a requirement. So it was very useful to give me a hand with that job. So we put 3 ambulances on just as a demonstration photo and show how we worked in the rain. So whilst those dynamic tests showed differences between the models, further information was required. The noise and vibration and ambos performing their tasks. So we've got a number of ambulance officers to conduct those patient tests over smooth and rough roads at 3 different speeds. And we're measuring the vehicle performance. So we had a matrix of road conditions, vehicle speed, and tests. And the tests were pulse taking, writing. These are the ambos, writing and listening, and rating each test. And while recording the vehicle dynamics and noise level. So I was a patient, they were taking my pulse, I had my pulse taken about 55 times, and so I was a patient amongst all our instrumentation. The outcome of this was that for the ambulance officers to perform their tests, if they want 15% certainty, then the ride comfort, it's got to be 0.1, and the noise, it has to be about 75.5 dB. Now, if I'm in an ambulance, I want more than 15% certainty it's going to work. So if you want 50%, then those levels are reduced to about 0.05 and about 73. But 50% is really not enough either. So I'd want 85% certainty. So therefore, the noise and the vertical acceleration have got to be reduced. And this was the outcome of that whole series of tests, and we presented that to them, saying, if you want your ambulances or the officers to be able to perform at these levels, then these are the operating conditions. And this was like a performance-based measure for them. So future ambulances had to be able to perform within those limits. There was other small consulting work. This was an operator who was bringing rolls of newsprint from Tassie, and he wanted to restrain them without damage, because if they're damaged, then they don't go on the machine so well. So he devised a restraint method using industrial glad wrap. And the load restraint guide says that you need 0.5 lateral acceleration, which is a 26 angle on the tilt deck, without load changing shape. So here was the newsprint rolls and the glad wrap. And as we can see, as we got higher, it failed. So in this job, I was only a sub-consultant, so I didn't write the report. I just gave them the data on the outcome, but it wasn't too good for that work. So other small consulting work was involved with load restraint guides for vehicles. Here's one with wool, another one with hay, round hay. Did some work for the Army. They had a stability problem with the vehicle carrying these armed personnel carriers. These vehicles higher than 4.3 metres with low density freight, and also for the Army. In fact, this was the Bushmaster, and I was a consultant to tell us before I joined them in 2007. And again, the Victoria Police, now, they had a problem with their bus safety. So again, here's my boss here helping with his hands in his pockets. And so I said to the Victoria Police, I need 53 people to load the bus. So here I am. I had these coloured cards to try and normalise the weight distribution on the axles of the bus. Now, these days, you wouldn't be allowed to tilt a bus with people in it. Anyway, that happened in those days. So other work we're doing on road trains. Here we were measuring the forces on the fifth wheel, and here we're measuring the forces on the pintle hook or the connections. We went out to past the Olgas out to the Giles weather station. Some other work we did trying to understand how much lane space various vehicles require. The longer the vehicle, the more wobble there is at the back. So we were measuring all that with these instruments and cameras and so forth. Also did lane change tests with that vehicle. And this was another vehicle we did up in Wyndham. So we had a range of tests. Anyway, so that's sort of a brief story of what I've been doing. So I hope you got some questions that I can answer.
Thanks, Rod. That was fabulous. Great presentation. What an interesting life you've had in your work journey. I am interested. Who's doing the research these days? You know, you're saying that. Did I hear you say ARB is no longer
in that business? Yeah,
doing this work.
Oops. Oh, sorry.
No, that's good.
A lot of that work now is done by computer simulation. So there's some of the people, well, we used to, I got to know a bloke at the university, aeronautical engineering, and I'd say to him, give us a list of your 4 best students, and they'd come and do vacation work for us, and then we'd test them, they'd test us, and then we'd give them a job, and they'd only stay for 12 or 18 months, but that was good because they were enthusiastic and they knew about computers and simulation and stuff like that. So, and then some of those, I was talking to one a couple of months ago, and he's gone out and set up his own business. But the thing about computer simulation is you've got to have good data to validate it. You just can't, go away and say, oh, well, this is how it works. But so that was in the latter years, that's what we did. We provide data for our companies to develop computer models. And some of that went out with these people, of course. But yeah, I'm not aware of of the intent of that research being done these days. Yeah.
But you've obviously been part of an era where there's been a lot of, I guess, as compliance has gradually crept up, you've been part of that development. And what's the thing that's most stuck with you that you felt most proud of or achievement in that time?
Yeah, well, there's a couple of things. That one, and that's what I did my master's degree on, was that one is they wanted to know how wide should they make a lane, you know, on a country road or any road. So we all know that like a B double has certain width, a B triple more, and a quad Roadtrain, but we didn't have any numbers on it. And so I set up a test where I drove, or I didn't drive, I recorded the performance of a number of different vehicles over different roads, rough and smooth road, different speeds, different loads, and come up with some information that allowed the road authorities to say, well, if you don't want them departing impinging on the lane next door for more than 3% of the journey, then it's got to be this wide. And that's what I did my master's thesis on that. Yeah, so that was one thing. But the ambulance one I was pleased with, because I had one graph that said this is the answer, mate, you know, and that was anyway. So yeah, so but I've done a variety of work. Yeah, up in the Northern Territory, those road trains was interesting. It's all been interesting in reflecting back on it. Yes.
Well, we're very grateful that you took the time to share that journey with us. It's been fantastic. So thank you very much for your time.
It's a pleasure. Thank you for hosting us.